Welkom, welkom. Het is nu net 11 uur, dus ik wacht nog heel eventjes totdat er wat meer gegadigden zijn. Voordat ik begin met een introductie van mijzelf en van Comago. Welkom iedereen. Ik zal het nog een paar minuten geven voordat ik definitief begin aan de introductie. In ieder geval fijn om al mensen te zien die al aanwezig zijn. Zoals jullie kunnen zien en waar jullie ook voor in hebben geschreven, gaan we het hebben over Sierra Wireless. Over de dingen die wij hebben gedaan met Sierra Wireless. En over wat er nog gaat komen van Sierra Wireless. Ik zal het nog een minuutje geven. Dat er nog meer mensen kunnen binnendruppelen. In ieder geval alvast bedankt voor jullie komst. En ik geloof dat onze gastspreker Dicken wel het een en het ander te vertellen heeft wat zeer interessant kan zijn. Ik zal me beginnen met voorstellen in ieder geval. Mijn naam is Tom Grootveld. Ik ben accountmanager bij Comago onder de shop mobiel verbinden. En bij mobiel verbinden doen wij alles wat bij Comago gerelateerd is aan 3G, 4G en uiteraard ook 5G oplossingen. Comago is een groot bedrijf. Wij zijn inmiddels meer dan 20 jaar oud. Wij hebben een magazijn en een kantoor in Utrecht. Daar ben ik nu ook. En in dat kantoor hebben wij ook voorraad van diverse producten, waaronder dus ook Sierra Wireless, om een voorbeeld te noemen. Wij leveren 3, 4 en 5G oplossingen aan zowel bedrijven als een klein beetje ook aan consumenten. En wij hebben goede banden, onder andere met Sierra Wireless en ook onze andere fabrikanten. En met Sierra Wireless hebben we ook al één heel flink project gedaan waar we ook mee in de publiciteit zijn getreden met de ANWB Wegenwacht. En we hebben die ruim 1000 MP70 units geleverd. Die hebben zij in minder dan 2 maanden tijd hebben ze die allemaal ingebouwd in wegenwachtauto's. De organisatie die daarbij betrokken was niets minder dan indrukwekkend te noemen. Ze hebben hun eigen software ook gemaakt voor op die Sierra Wireless routers. Zoiets staat ook in de whitepaper te lezen van de ANWB Wegenwacht. En we hebben de MP70 ook op andere locaties ingezet bij marineklanten, onder andere. Ook hebben we Sierra Wireless bij elektrische laadstations ingezet. En ook hebben we voor weg- en railstransport gewerkt met Sierra Wireless. Ook leveren we in Nederland heel veel uiteraard, maar ook verder buiten. Er zijn maar weinig Europese landen waar wij op dit moment nog niet aan hebben geleverd. En ook internationaal, buiten Europa, kunnen wij leveren indien dat nodig is. Waardoor wij dus een sterke speler zijn op het gebied van 4 en 5G connectiviteit. Mede dankzij de deskundigheid van mijzelf en van alle partijen waar wij zaken mee doen. One of those parties is Sierra Wireless. We often have contact with Dicken Robinson of Sierra Wireless. He has been working there for nearly 8 years now at Sierra Wireless. And he has been working in the field as a pre-sales engineer for over 20 years. And not just with Sierra Wireless, but with other companies as well, which gives him a very good advantage with knowledge, not just about Sierra Wireless, but other items as well. Dicken, I would invite you to introduce yourself perhaps, and then maybe start your presentation.
Thank you very much, Tom. Hi, everybody. My name is Dicken Robinson, as Tom said. I'm head of pre-sales engineering for Sierra Wireless for the gateways and routers in the EMEA region, which is why I work with Tom quite closely. We've worked on several projects, such as the ANWB project that he mentioned, using the MP70 used as a vehicle area network within their emergency response vehicles, or their vehicle response vehicles. So what we're going to talk about today is LTE 5G and some of the gateways and routers that we use in the mobility sector. And we've got a rich heritage of gateways and routers in mobility. And we're also going to look at some of our products that are going to come out in late H1, so around about May, and then again later on in the year as well. So if we go to the next page, 5G networks, what's new with 5G? This is just a timeline of how everything's been evolving now. We started with Edge, GPS, GPRS, CDMA, and then went to 3G, and then 4G, and now we're just coming into 5G, which is bringing in the new radios. The big difference between 3G and 4G, there's a definite change. You have a 3G technology, and then you have 4G LTE technology. The difference with 3G, 4G change and the 4G, 5G change is that 4G and 5G work with each other. So you get a combination of 5G and 4G. So that really enhances throughputs and things like this, but you're not suddenly making all the 4G networks redundant if you're moving everything to 5G. They work in combination with each other. And eventually you'll get some what's known as 5G standalone networks, which are pure 5G. Moving on, any questions, just let me know. Now the 5G promise, speeds up to 20 gigabits per second, capacity 100 times more than LTE, and really low latency. Now there's a couple of things to note here. Up to 20 gigabits per second, that is a theoretical maximum. The peak data rate that's expected in an urban environment is round about 100 megabits per second. Because you're going to get so many users on a base station, on an eNode B, 5G base station, that you can't give everybody 20 gigabits per second at the same time. So you've got to share it out. As you can see in that blue screen there, that's a test that was done in November on a 5G network in the UK. And that's on a live network. And we were seeing 734 megabits downstream and 91 megabits per second upstream. And that was on an earlier version of firmware. We're now seeing, with our latest firmwares, we're now seeing round about 1.2 gig down and round about 120 megabits per second upstream. So this is something that's really coming along, these higher speeds. The latency part. Now, I mentioned before that 4G and 5G work together as a combination. You're not going to get the low latency when it's in that type of situation. When the network operators do get their pure 5G networks up, so you're not touching any of the old LTE stuff, but you're pure 5G, then you will start to see lower latency. These networks are called standalone or SA networks. 5G SA is a term that's often used. And that will be coming, but having this ability to combine 4G and 5G together gives network operators a progression to move from 4G to 5G. It's not suddenly just a cut over, switch off the 4G, switch on the 5G. It gives them a chance to upgrade everything. Ultra low latency requires the rollout of standalone networks, which I was talking about. 4G and 5G will coexist, and that will be for quite a long time as well. 4G is not going to go anywhere. 3G is being switched off in Europe, but 2G isn't. Where it's different in North America, where they're switching off 2G and they're keeping 3G. Very good. Commercial availability varies by country and by carrier. It's a slow rollout. People have to put this stuff into their infrastructure. And performance will be highly dependent on the bands used. With the 5G, you've got these new bands. We've got something called the 5G NR, which are bands up to the 6 gigahertz. And then we've got what they call the millimeter wave bands, which are the bands above 6 gigahertz. So your 10 gigahertz, 24 gigahertz, 28, 69 gigahertz. But we have problems with those. They're not really good for a mobile environment. Because of the frequencies that are used, the distances are greatly reduced because of physics and the way that cellular technology works and radio technology works as a whole. They're susceptible to rain, they cannot penetrate buildings, all this sort of stuff. So what we've done at Sierra for our gateways is we've concentrated on the sub 6 gigahertz bands, which is we are still seeing these high data throughputs. This is our current portfolio of this is our 2020, 2021 H1 portfolio. And so we've got our standard Essential Series gateways, our Elix 40 and Elix 60. They're both Cat 4 or Cat M1. And then we have, these are used for lighter environments. They have plastic housings. Their IP rating is 2021. So they're not that ruggedized, but they do have E-marking, so they can be used in vehicles. They support LTE Cat 4. And there goes the doorbell. I apologize for that. Then we have our performance series. Now, these are our ruggedized series of routers. So we're talking about the RV55, the RV50X, and the MP70 and the MG90. Now, these are either Cat 4, Cat 6, Cat 12, or 5G, depending on what type of device you buy. We're going to talk a lot about the MP70 and the MG90 today, because this is more used in a vehicle environment, because we're able to set up what's known as vehicle area networks. The MG90 is our current 5G device. So it will have either 1 or 2 5G radios inside it. It's available now, limited availability as of the end of this month. We're starting to do field trials now with it. But as I said, it's a sub 6 gigahertz 5G router. It also supports 4G LTE Cat 20, and it's naturally MIMO. It has dual Wi-Fi. MP70 is a Cat 12 device, LTE Cat 12, and has a single Wi-Fi. Then we have other things like the RV55. These are all smaller, but they're all ruggedized. They're all in aluminium casing. They are IP64 rated, so they're made to go into harsh environments. They're tested to a particular standard called MIL Standard 810, which is a military standard used in North America. So they are tested for real harsh environments, for shock and vibration, for overvoltage, and all these sort of nasties that come about. If there's any questions, please let me know. We're going to talk about the MG95G. So this is ideal for existing customers and current prospects because it's the same as we did have an MG90 4G. And now what we've taken that MG90 platform and replaced the 4G radio with a 5G radio inside it. So it uses the same footprint, it uses the same firmware as before, called MGOS. It's the sub 6 gigahertz and LTE Cat 20 and something called 3GPP release 12. It's actually, I say 3GPP release 12 because that's something that law enforcement or emergency services in some countries are looking towards. It's actually 3GPP release 15 compliant. But I say release 12 because the way that emergency services are trying to are moving away from Tetra and they're moving towards cellular networks. And they want to be able to have priority over general traffic. And one of the standards brought in by 3GPP release 12 was the use of something called QCIs. Now, QCIs you could class as quality of service over a cellular interface. And there are different QCIs that are used. Standard QCI for everybody is QCI 1. That's what you and I use on an LTE network. QCI 7 is for data traffic, but has a higher priority over standard users. So police forces, this is happening in the UK in something called the Emergency Services Network, where they're using this QCI 7 for their data traffic, their standard normal data traffic. Whether that be maps or whether that be ANPR or that would be video feeds or whether that be heart monitoring machine, is using this quality of service over the cellular interface. And then there's another one called QCI 70, and that is used for instant messaging. It's a very low bandwidth data channel, this QCI 70, but it's used for the special messaging that you send. Say you press a button, it says police vehicle on site, or you press a button and says my lights are gone, or you press or you send another message saying go to this location or arrived at this location. This is really high priority traffic that's absolutely mission critical, and that's what 3GPP release 12 is talking about. In North America, they've gone a completely different way. They've actually taken a separate band. And this separate band, band 14, LTE band 14, is purely used by the emergency services across the whole country. Now, there's different countries in Europe are taking up different stances. Some are looking at using band 28 as a standalone band. Other countries are looking at the 3GPP model. We're capable of doing either and all. As I said, this is targeted at field utility, field workforce, utility fleet, public safety, transit, passenger Wi-Fi, and fare payments. The MG90 has been introduced into buses in Italy, for instance, where because of its multi-networking capabilities and it has its dual Wi-Fi, what we're doing with buses in Italy is that one of the Wi-Fi radios is being used for passengers to be able to connect to. Another Wi-Fi is actually being used as a client, so that when the bus enters a bus station or a bus depot, it can connect up to the local access point. And so rather than sending any data over the cellular network, it can use the Wi-Fi network. It has dual radios, 2 radio modules. So you could have 2 SIM cards from different network operators. So that if you're going into certain areas where you know that this particular network operator doesn't work well in this area, it will automatically send the traffic over the second network operator. We're also connecting up payment machines to the Ethernet ports or through Wi-Fi, because you can have multiple SSIDs. And then payment data can be sent through a VPN to a payment server or a counting server. And it's the same with video. So this is being used in multiple locations. I just brought one up that was Italy because it's something I've recently been working on. Any questions? Okay, the challenge of vehicle networking. Vehicle area networks is what we call VAN. So these are all the devices that are connected within a vehicle. You've got many moving assets and mission critical applications, especially within the emergency services. And then you've got private networks, public networks, and Wi-Fi's. These are the WAN interfaces that we can use. We want to be able to route traffic over the correct WAN interface. So we're able to do that with our devices. And then it passes all the way back through to the enterprise network. And then we have the network management. We've got to manage all these devices. We've got to know where these devices are. We have to understand all this. So security is important as well, because it could be important data that we're talking about. It could be secure data. It could be people's private details, and you do not want that being shared over a cellular network. So we have to go through some way of preventing that happening. So we're looking at a vehicle network solution here. So we've got the Wi-Fi and the LAN. So we're connecting up different parts of the vehicle, such as the CAN bus. We can connect to a vehicle's CAN bus. And then we're able to take that CAN data and present that on a management platform, such as things like throttle position or fuel level or revs or engine speed or all sorts of different stuff that we're talking about. We can connect up tablets and body-worn cameras and PDAs, specialist PDAs. We can connect up cameras. And then we've got these different streams of traffic, but they're going to different places. So we can separate these traffic streams out and route them to different places over different WAN interfaces. You might not want to send video traffic over a cellular interface. So we can set up rules to say, only when I'm connected over Wi-Fi will I offload my video. Otherwise, it stays on a hard drive inside the vehicle. This is quite a common use case. And then we have to secure everything. We have to make sure it's secure. So we have to enable VPNs. And we have to meet certain security policies, which we do. We're very good. We're very high on security now. It's really quite important. And we have to be able to manage these devices in the field, which we do. We have multiple platforms that we can use to manage our devices and the devices behind those devices as well. Our devices have something called dead reckoning. Now, dead reckoning is, of course, all our devices support GNSS, so GPS and BIDU and GLONASS and and GQZ, QZSS, these different satellite constellations. But if you're in a tunnel or if you're in a multi-story car park, you don't really know where that vehicle is because it can't see the satellite. It can't see the sky. So we have something in there called dead reckoning, which is a 9-axis accelerometer. So using that in conjunction with the GNSS, we can identify where a vehicle is. And here are some examples. So in a tunnel, when we look at down there and we look at Burrard Landing, we can see if it was pure GNSS, it's all over the place. But if we include the dead reckoning feature, which is, it's a standard feature, it's nothing extra, we don't have to pay for it or anything like that, we could get a much better idea of where that particular bus went. Same again in urban canyons. People think, oh, I can see the sky up there. But if you've got lots of tall buildings, you actually can be obscuring access to the satellites in the sky. And that is also important. And the last one was in covered car parking. This was actually in IKEA in Richmond, which is just down the road from our headquarters in Vancouver, in Canada. And you can see a big difference between GNSS only and the dead reckoning. Where we've enabled dead reckoning, you can see where a vehicle was driving through a car park. We enable mission critical mobile IoT applications. This is a typical police car using an MG90, and we are able to get vehicle telemetry. So the engine diagnostics, we're connecting up DVRs, we're connecting up Wi-Fi to laptops, we're connecting up ALPR, what we call ANPR, automatic number plate recognition cameras. We're connecting up cameras, basic cameras on the rear and basic cameras on the front. We're connecting up all these different devices, whether that's over Wi-Fi or over Ethernet. And then we've got our different WAN interfaces, such as Wi-Fi, public cellular, private cellular, because private networks are something that we are seeing more and more interest in. And we support these private bands. Absolutely, we support all these private bands like band 41, 42, 43, 46, 48, 49. We support these private bands so that we can fix our devices so they'll only work on those private bands. We also support Ethernet as a WAN interface so that we could connect up to a satellite terminal, for instance. This has been used in some shipping applications where when a ship is on the high seas, it's using its satellite, but as soon as cellular is coming in closer to the coast, cellular is available, all data is then routed over the cellular interface. And once it gets to the dock, they connect up to Wi-Fi. So all data is routed over the Wi-Fi interface. So we're able to use these different interfaces to route our Wi-Fi. This is looking at ambulances. We do a lot with ambulances. Telemedicine is something that's increasing greatly. And so people back in hospitals, doctors back in hospitals, want to be able to have live pictures or live diagnostics of an incident of where someone's been taken ill, whether that be a crash, whether it just be someone who's cut themselves or whatever. They want to be able to see this. And so using our high-speed router in an ambulance is something that's really important. And once the vehicle gets to the hospital, they already know what type of state a particular patient is in. So they can be prepared for when they do arrive, we can actually get onto this and help them. Same with the fire services. We're starting to roll out fire services. They're the early takers of ESN in the UK. And so the fire services are starting to use these routers in their deployment so that they're able to take messaging data. They can connect up their cameras. They can connect up their body-worn cameras as well, so that when they're going inside a burning building, you're getting live pictures, or if it's a car accident, They're taking live pictures of a car accident, what sort of state the car is in, and if there's any injured parties inside the car. Also, we also do something called Wi-Fi tags, so that for high cost equipment, you don't want to leave it behind at a scene. So we have these Wi-Fi tags. If you drive off, the Wi-Fi tag will alert you and say you've left a part of your fire engine behind, go back and pick it up. And again, this is all about security. Because this is national security, we have to apply to the basic security standards, and which we do very much so. And again, utilities. This is something that we could look at ANWB, for instance. Network complexity, many available communication systems, public, private, radio, cellular, satellite. There's all sorts of ways to connect up vehicles. But you want, if you've got these vehicles are possibly on the road all day, you want to be able to know where those vehicles are, what's the best route for them to go to their next job. They need, you need to look after your workers. So there's a safety aspect to this as well, whether that be by camera, by monitoring. So you're monitoring your worker is what the guy's trying to do in a dangerous situation. So you might need to send someone else out to help them or whatever. So that you can effectively look after your workers and the jobs that they do, and so reducing cost and increasing efficiency. This is used a lot as ANWB took up this option in their vehicles. Another large instance I can think of is Duke Energy in North America, where their whole of their workforce, this is their actual pictures of Duke Energy, where they're working, they're using our devices inside their vehicles. Again, they're using MP70, same as NWB. You don't need the complexities of something like the MG90 for something like this at the moment. I mean, that might change in the future, obviously. Just to let you know, 45% or above 45% of the US population is protected by Airlink routers, by Sierra Wireless routers at the moment, by state police agencies. And these are just a few of who we are looking after, like California State Highway Patrol, Massachusetts, Arkansas State Police, all this type of stuff. So we are heavily involved with the emergency services. We could also say the same for the fire departments and for the ambulance. Now we're going to look to see what's coming in the future. This is what's coming later this year. We've got a brand new product. We've got several brand new products, actually. And this one is called the XR platform. And it's going to be running something called Airlink Os. We've been working for 2 years on a new operating system for our routers and gateways. And at the same time, we've been working on a brand new platform for our gateways. And we've called this the XR series. And we've called the operating system something called Airlink Os. And this is what is coming. The XR90 will be available mid-May of this year. I've been doing testing with it. It's a modular device. It's very much centered around the high-end market, the XR90 to begin with. So for vehicles, it includes things like dual 5G radios. It includes Wi-Fi 6. And it's got many more routing capabilities than our existing range at the moment. So we're talking zonal firewall and stuff like this. So have a look at it. There's a picture of it. And we're going to start introducing Airlink Os into our existing products. This gives us extra functionality. This won't be happening until later on in the year, the Airlink Os. It won't be happening on the MG90 or the MP70 at present. And you can see we're entering another 2 devices, something called the XR80 and then something called the XR60. These are all going to be 5G devices. These new hardware is going to be 5G devices with 4G and 3G fallback. Okay, that's something that's also happening, but they're including Airlink Os. The thing about Airlink Os, it's multi-WAN routing capabilities on it. And let's talk a bit more about them. So the XR80 and XR90 5G, if any of you have ever seen our Elix Os Manager, this center picture shows you how different it is. This is very much an upgrade on what we're capable of doing.
Dicken,
yeah.
Question from the audience.
Sure.
Will the XR series also have 2G fallback?
Not at the moment. I'll explain something in a minute about both the XR80 and XR90, which might assist you in something there. Because 2G is very low data rate, but it's good for purely connecting to a device. And that we do have something else on the XR series, which I'll talk to you about, which might help you there. So we've got the Ellic OS, which is completely different. It's a different look. It's much cleaner. It's very easy to use. It gives you a lot more data and it gives you a lot more capabilities. And we also support these trip reports in our ALMS, the Airlink management system, which is our cloud, which is a standard management platform. And we're adding extra functionality so that we can do trip reports. We can imprint on a map, show where a device was going, and we can set those thresholds on a map so that where someone was going at a high speed, low speed, or an average speed, or whatever, you can self-configure those thresholds. Now, it's supercharged performance and edge intelligence. So we're going to add edge intelligence to these devices. We'd had it before with our Airlink series, with the Elix devices, such as using Lua. What we're including now is a Docker type environment for the Airlink XR series. So we're going to add different, it's not just going to be a Lua scripting. We can add this complete Docker system included in that. It's flexible. It's IPv4 and IPv6 routing of firewalling. It's secure networking, platform management, and a response user experience provisioning. In Elix, if you make a change, you have to reboot the device. XR series, there's none of that anymore. You just make the change and that change is applied once you click on save. Just to make sure that you want to make that change. And it will tell you if you've made a mistake. When you do, if you apply a setting, it'll tell you, no, I can't do this. You've made a mistake. Please go back and visit it. It's faster. It's going to be 10 times faster. It coexists with 4G. 4G is not going away. Real-time controls, slower latency. The problem with 5G is you're using faster speeds, so you're going to require more power. When you use more power, there's more heat dissipation. That's just not the 5G modules. It's also the processor inside the gateway that has to work with these high speeds, with this high-speed data to process it. And it's a ruggedized, mission-critical design. Again, these are really strongly built. So we've designed it from the ground up to help with the power and the thermals for the heat dissipation, so that it's still a fanless device, so that we can still have the higher IP rating, IP64 and MIL standard, with 5G performance, fully compliant with industry such as rails, vehicle, hazardous environments as well. So class 1 div 2, so we can go in gas environments or the like. We have one Ethernet port, is a 5 gigabit Ethernet port. The other Ethernet ports are all 1 gigabit Ethernet port, but one of them can be configured as a 5 gigabit Ethernet port. which could be used as a WAN or a LAN interface, whatever way you want to use it. It's entirely up to you. It's fully configurable. Sub-second switching with cognitive wireless, so that we can identify when a wireless link is down, it will be a sub-second switching data from one wireless interface to another wireless interface. Or you could route traffic over different wireless interfaces at the same time. We do not do channel bonding. Straight out the box, we do not do channel bonding. The problem with channel bonding is the overhead required when it gets to the far end to reconstitute that traffic. There might be different latencies from one WAN link to another WAN link. For instance, if you're using Vodafone on one WAN link and you're using BT on a different WAN link, their latencies when they get to the other end means that the overhead that required to correctly reconstitute a data stream, it negates the use of any benefits of having channel bonding. Channel bonding is fine for wired links, but over cellular links, it can be a real pain. We have something called out-of-band management. We have a third radio inside the devices. This is where I was going to talk about the 2G. We have something called, we have an LPWA modem that we used, that can be used as a failover purely for management traffic, and it will connect up automatically. So it's zero touch provisioning on this. And so you'll always have access to a device, unless it's underwater or something like that. You'll always have RF access to a device from a management platform. As you can see, this picture here, this is the XR. It has 5G, 4x4 MIMO, 4G Cat20. It has Wi-Fi 6, 4x4 MIMO. This is the XR90 we're talking about here. It's expandable. As you can see here, we can add or take away a radio module. And with that radio module comes an extra Ethernet port. Okay, so we can add or take away a radio module. So you can get an XR with one radio module, 5G radio module, or with two. Or you can buy a single, initially with a single 5G radio module, but oh, I want to add another 5G radio module. So you just buy one and put it into the size. It's fully ruggedized. It's bolted on and it's very, very secure. We got standard RS-232 on an RJ45 interface. So similar to the way Cisco has their console ports. We have software-defined networks, zone-based firewalls, and as I mentioned, the out-of-band management, and USB-C, as you can see there as well, moved away. And this is where we sit. This will be our portfolio. As I said, those dates are slightly, limited availability, 30th of April, possibly. I suspect that to be round about mid-May, actually. Limited availability for the XR80, we'll look at the differences in a minute, is round about, 30th of June, looks about right. And then public launch, May 21 for both devices. So that will be our portfolio as of, you could say June this year. So 3 months' time, 3 or 4 months' time. So this is where the use cases. So the Airlink XR90, larger vehicles with long service lives, transit and public Wi-Fi, dual cellular failover. XR80, police vehicles, fixed wireless, industrial edge. The difference here is the XR90, inside it is dual 4x4 MIMO Wi-Fi. And then on the sides, we add the 5G radio modules with their extra Ethernet ports. In the XR80, there is already one 5G module inside it, and we can add an extra 5G module if we want to. I'll talk about the connections in a minute, but the There are two Wi-Fi radios inside the XR80, but one is a 4x4 MIMO used as an access point, and the other one can be used either as an access point, but mainly designed to act as a client, and it's a 1x1 antenna. So looking at the XR80, as we can see here, this is what it looks like front and back. You'll notice we don't have any SMA connectors anymore. We've moved away from those to FACRA connectors. This is far easier for adding, connecting cables. They just click on and click off, and they are very secure. They're used in the auto trade, and they're used a lot. So we've picked up that. Putting on and taking off SMA connectors, it can be very fiddly and difficult, especially if you're in a tight space. As we're looking at an industrial edge compute, low latency, high speed, rapid site connectivity, excellent. We're trialing these currently in North America for these particular types of workforce. Multi-network routing. So it has a single 4x4 5G cellular, but you can add an extra 4x4 5G cellular if you want. And it has dual concurrent 5x4 Wi-Fi 6, as I mentioned. It uses the sub-6 gigahertz bands. We do not use the higher frequency millimeter wave bands of 5G, as I mentioned before. Just a bit more information. We have, by default on the XR80, is one 5 gigabits port plus two 1 gigabit Ethernet port, or you can add another one as well when you add a second 5G radio on top of it. Dual SIM slots, both of them. An 8-pin Molex GPIO, so we support GPIO, so that's 5 digital or 2, or of which 3 could be analog. And we also have a native CAN bus connection, USB-C port, programmable reset button. It's got discrete GNSS with dead reckoning as well. And we have this LPWA radio for outer band management. And you can see this is a closer view of the rear side of it. And they're color coded. All of the, so the cellulars are this purple color, the Wi-Fi, the yellowy white color, and the GNSS is blue. And they're push on and click off. And these are the expansion cartridges. An expansion cartridge used on an XR90 can be used on an XR80. They are exactly the same. They're bolt on, bolt off. And they're very rugged. The XR90, it's the one up from the XR80. So we have, it comes either as a dual or a single 5G cellular, and they all have dual Wi-Fi 6, 4x4 Wi-Fi 6. Looking at the larger vehicles, transit passengers, Wi-Fi, fare payment, video in car, body cameras, all this sort of stuff. It's the high end of product. And it will be using Airlink Os again. And there's some more, as a better idea of it. It comes with one 5G Ethernet port plus two 1 gig, and then there will automatically be another 1 gig port if it's a single radio, or another Ethernet port if you're using two cellular cartridges. So a total of 5 Ethernet ports. Again, it has GNSS, it has a reset button, it has Bluetooth, something that the XR80 does not have. The XR90 does have Bluetooth as well. And we can see the rear of the XR90 there. Quite self-explanatory, really. Why is Wi-Fi 6 important to customers? Well, we get greater speeds, substantial increase in speeds over Wi-Fi 5, increase network efficiency. It borrowing the concepts of LTE to give spectral efficiency, so you can communicate with multiple devices simultaneously and not just one device at a time. It supports 2.4 and 5 gig, and scheduled wake up to improve battery life. This is the way that we have the XR80 and XR90, how the Wi-Fi 6 is implemented in each of them. So we can see here one 4x4 to act as an AP and one 1x1 to act as an SDA, scanning for depot access points. And this is just to illustrate that any data from anywhere can be routed over any WAN interface, and they can be secured. We obviously support VPNs. We support multiple VPNs. We support multiple APNs on the SIM cards as well. So you might have one SIM card and have different APNs. You can route traffic over different APNs. So I want video traffic to use this APN. I want customer data. I just want whatever data, internet traffic, camera traffic over one APN, internet traffic over APN 2. We're able to route all this as it's a fully blown router. And we use hardware acceleration. This is important for VPNs, for instance. So the processor inside the device is not having to process the encryption. We're using hardware to do this. So it takes a big load off the processor and makes things faster.
Dicken, how are you for time? We have about 10 minutes left.
Yeah, I'll be about another 5 minutes.
All right.
Just a couple of things. I'm going to quickly go over Airlink Os Basics, which is a big change from us. Taking the best of what we have in Alios and MGOS. MGOS is used on the XR90s. Alios is used on the LX series, the RV, and the MPs. And we're taking it. We've added new features such as zone-based firewalls, multi-LAN without the limitations of a default interface. There is no default interface anymore. You can set a default interface if you want to, but by saying there's no default interface. We're supporting multi-APNs now. We're doing new monitoring. We can monitor IP flows, neighbor table, the routing table, new diagnostics. We support IPv6 now. Backup software, non-destructive upgrades, simple blackout, and customizable system reset templates. So if you reset it, it doesn't, you can say, I don't want it to actually go to factory defaults. I actually want it to go back to this particular template, these particular settings. This is subject to change, but this is how it's starting to look. This is what I use at home while I'm testing. We've got stuff, we're integrated with Google Maps, as you can see on there. It's telling us what type of device it is with a picture. It's telling us what WAN interfaces are up. The LPWA, the XP Cellular 1 and XP Cellular 2. This is an XR90, obviously, because I've got two MP70s up. Sorry, two cellular interfaces up. And then it's got a whole LAN interface. We're looking at all of our different LAN, what's connected in Ethernet 1, connected on Ethernet 2. On XP1, whatever we're looking at. And we look at CPU load, memory storage. We're getting a whole lot more information readily available. We also support, it's obviously going to be supported in our cloud management platform. And we can set it so that all management traffic goes over the LPWA modem if you so want. Or by default, it always uses, the management traffic will always use the fastest route, but it will fall back to the LPWA if your 5G modems aren't connecting up for some reason. Because LPWA uses Cat-M1 or MV1. It gives a lot greater distance than 5G cells will ever give. It's a link of last resort. And we support, we obviously have new antennas, specially designed for this. So a 10-in-1 and a 9-in-1 antennas that are used for these devices. And that's it. Any questions?
I currently don't have any open questions here, but perhaps if anybody would like to ask a question, we can then answer them live.
Sure.
It was a great presentation, by the way.
Thank you.
Good information, I think. It's also nice to have a sneak preview of what the Airlink Os can look like.
One thing I did mention there was the LX60. That will be another smaller device. I have only very few details on that. It was announced at the beginning of February, but it probably won't be available until about this time next year. It's going to be a small 5G device. So something the similar size of an RV, I'm expecting, but with 5G capabilities. The problem with 5G is that the 5G chipsets that we use the Qualcomm chipset. They're very, very expensive because they're brand new. It was the same with LTE. When LTE first came out, the chipsets were very expensive and now they're a lot cheaper. It's all to do with supply and demand. So once the chipsets become cheaper, then the possibility of creating smaller devices that are more cost effective will also be available.
I do have one additional question.
Sure.
Which is to the FACRA connectors rather than the SMA.
Yeah.
What was the reason for choosing that connector?
Oh, right. Okay. The reason for choosing it is the ease of putting it on and taking it off. SMA, the space to get a tool in to tighten up an SMA connector can be quite difficult. It can be even just getting a tool in there to tighten it up because the distance between the connectors is small. Because we're putting so many connectors on the back side of a device, because we've got, for instance, on the MG90, you've got 4x4 cellular on each side. You've got 4x4, two lots of 4x4 Wi-Fi. You've got GNSS and you've got Bluetooth.
That is a lot of connectors that you would have to tighten.
Yes, and it's really difficult with a FACRA connector, which is an industry standard for mobility. You have them in all your cars, whether you know it or not, nowadays. It is, all our devices go through shock and vibration testing. As I said, the MIL standard 810. And these pass those tests with flying colors. So there's not a chance of it falling off. They're also key coded so that you can't put a cellular connector onto, or a cellular antenna cable onto a Wi-Fi antenna cable because they're keyed. Same with the Bluetooth. You can't put a Bluetooth on a cellular or whatever. There's different keys. So you'll know that you're always going to get the right connector onto the right antenna type. Whereas with before, you could mix and match. But yeah, it's ease of use mainly, and the ability to save space.
All right, that is a brilliant answer. Thank you, Dicken. I see no new questions in the meantime, and I would definitely like to thank all of the attendees for their attention in this presentation. I'm going to stay online for several more minutes. If you have any more questions, please do not hesitate to ask them. Now is your chance to have them answered by Dicken, a professional. So for those that have joined us, thank you very much for your attention. Thank you for this morning, Dicken, as well, for your presentation. And I'm going to stay here for a little while longer.
You're more than welcome, Tom.
there seem to be no new questions.
Okay. Well, thank you very much and have a great week.
Thank you, Dicken. It is also now 12 o'clock. So I'm going to end this webinar with my thanks to all of you.
And to you. Bye-bye.
Bye-bye.